Dear students, welcome to another session of Nuclei chapter. Today we will see the topic binding energy curve. Okay, so binding energy curve, it's a simple idea, like we take binding energy per nucleon in the y-axis and mass number along the x-axis, and we are going to compare like the binding energy per particular mass number, okay, per elements of particular mass number. So you can see from here, so below 25 or below 30 you can see it increases, actually binding energy goes on increases for different elements. Then after certain interval, like you can take from like 30 to 170, you see that binding energy is nearly, binding energy per nucleon nearly same. And you can see after this 170 again it decreases. So the definition, we can say that it's a curve between binding energy per nucleon and mass number of various nuclei. Okay, it is a curve between binding energy per nucleon and the mass number for various nuclei. So this is known as binding energy curve. Now we can see some of the ideas we can derive from this one, that is binding energy per nucleon is almost constant for nuclei of middle mass number. That's what I told. So from mass number 30 to 170, you can see that, see from here, that is mass number 30 to 170, you see that binding energy per nucleon remains almost constant. Okay, nearly constant, we say that. Then binding energy per nucleon is small for both light nuclei and heavy nuclei. So binding energy per nucleon is small for light nuclei, that is A less than 30 and A more than 170. So A more than 170 and A less than 30, you can see that binding energy per nucleon value remains small. Then nuclei with atomic mass number 56, that is iron, has highest binding energy per nucleon and the value is about 8.75 mega electron volt. Okay, now what does this binding energy curve gives? The idea what the binding energy curve gives is the stability of the nucleus. When binding energy curve indicates the stability of the nucleus, greater the binding energy per nucleon, okay, will tell you the stability is also greater. So greater the binding energy per nucleon value, greater will be the stability of the nucleus. When a heavy nucleus, okay, we can see that when a heavy nucleus splits into two smaller nuclei, okay, binding energy per nucleon is more for these lighter nuclei. When a heavy nucleus splits into two lighter nuclei, binding energy per nucleon will be greater for the lighter nuclei. Okay, so large amount of energy will be released in this process. Large amount of energy will be released in this process, and this process is known as nuclear fission. So I am just giving you a brief idea of that. When a heavy nucleus breaks into two lighter nuclei, large amount of energy will be released. So this process we will discuss in detail about nuclear fission. Okay, next one, when two lighter nuclei combine to form a heavier nucleus, binding energy per nucleon will increase. As a result of that, large amount of energy will be released. So here also you can see that when two lighter nuclei, they combine to form a heavier nuclei, what happens? Large amount of energy will be released, and this process is known as nuclear fusion. So this also we will see in detail in the coming discussion. Okay students, next topic we will see about nuclear force. So nuclear force is considered to be the strongest force in nature, right? Okay, so why this nuclear force is very important? Because you can see that inside the nucleus there are nucleons. So it is necessary that these nucleons should be held tight, correct, right? So you have seen in the previous idea of atom, nucleus at the center, electrons are revolving around it. So there is a force of attraction between this nucleus and this electrons. So there is a force of attraction. That's the reason why electron is able to revolve in the circular or elliptical path. Now the force which is inside this nucleus, which holds, okay, the neutrons and protons together. Okay, the force which holds the nucleons together tightly inside the nucleus is known as nuclear force. Okay, it is a very short range force. You can see it will not act beyond the range of the nuclear size. Okay, but it is the strongest force in nature. We will see some of the characteristic properties of nuclear force. Okay, nuclear forces are strong attractive forces. So nuclear forces are strong attractive forces. So that's the reason why neutron and proton inside the nucleus is strongly bind together. Okay. Next one is about nuclear force is charge independent. So how do we say charge independent? The force of attraction between neutron and proton, or neutron and neutron, or the repulsion between proton and proton. So they are all same. Okay, the force, the magnitude of force is same for all these type of interactions. So we say that it is charge independent, doesn't depend on charge. Otherwise we can say like the force of attraction between neutron and proton is stronger than the force of attraction between neutron and neutron, like that. It cannot be like that. They all have the same magnitude of force of attraction, or we can say that here it is repulsion for the proton and proton. Next one, nuclear forces are short range forces. So what is the meaning of short range forces? Short range force means it can act only up to certain distance. So if I consider a nucleus, this nuclear force will act only up to the boundary of the nucleus. So we say that it is 10 to the power minus 15 meter. So nuclear force cannot act beyond that. Correct, right? So it is a short range force. Similarly, if the nuclear size we take lesser than this 10 to the power minus 14, we say that nuclear force slowly becomes zero inside. Okay. Next, about nuclear forces have saturation character. What is the meaning of saturation? Saturation means saturation means we can say like the interaction is not with all the nuclei inside the nucleus. So nucleons can interact only with the neighbors of it. Okay, so limited number of neighbors can have the interaction. So that's the reason why we call it as saturation character. It cannot, the one nuclei if I consider, it cannot interact with all the nucleon. Okay, so it has to have a limited number of interaction. Next is about nuclear forces are non-central forces. What is the meaning of central forces? You have seen in your first year the centripetal force. Okay, it acts like towards the center, right? So a body revolving in a circular path will be attracted towards the center, we say. Okay, so forces act along the line joining the centers. So central forces means in the certain forces which act along the line joining the centers. But here if you consider these nuclear forces, they are not central forces, they are called non-central forces. Then the interaction between the nucleons inside the nucleus will not be central. Okay, the force won't act along the line joining the center. It will be like certain, maybe slightly different from the exact center. Then this will denote us that the distribution of the nucleus is not spherically symmetric. We cannot have a exactly spherically symmetric structure for the nucleus. Next one, nuclear forces are spin dependent. There are two types of spin. One is parallel spin and another one is anti-parallel spin. So we observe from the studies that nuclei having parallel spin will have more interaction, okay, compared to the nuclei having anti-parallel spin. So this is about interaction is spin dependent. So spinning means you must be knowing, right? Spinning means rotation. So if you go in detailed study about nucleus, you can say that like a lot of fundamental studies are there, but it's not important for the time being. You can just study the properties. So this question may be asked for 3 mark. There is a chance of getting this question for 3 mark. So maybe like or 5 marks also it will be asked, like 3 plus some extra question. There is a chance, okay? Not exactly like 3 mark, maybe like sometime for 1 mark, or another along with another question for 3 mark, maybe like that. So next we will move on to radioactivity. So radioactivity is one of the major field where a lot of scientists have worked and a lot of discoveries had happened. You must have heard about Madame Curie or Marie Curie, right? So Madame Curie and her husband, okay, Pierre Curie, had worked so much in the field of this radioactivity. They had discovered mainly like Madame Curie had discovered 2 elements, that is radium and polonium, and she is the only woman must be having Nobel Prizes in physics as well as chemistry, okay. So actually they were not the first one to start with the idea. It was Henry Becquerel in 1896 studied the first ideas, or he understood the first ideas about radioactivity. So uranium he had kept in a foil, okay, uranium kept in a foil, and he observed that the photo plate which is kept somewhere near to that was getting affected with the presence of this uranium. So uranium was kept in a foil, okay, it was bounded in a foil, and the photographic plate which was kept somewhere near to that was getting affected with the presence of this one. Then he came to know that there must be some kind of interaction, or maybe some kind of particles or waves or energy is getting emitted from this uranium, and that was the reason why photographic plate was getting affected. So from that they started studying about that. Then they got the idea, like if you take a radioactive element, it is going to liberate energy. So energy may be in the form of wave or maybe in the form of particle, okay. Then we can say the process of radioactivity, it is a spontaneous disintegration of nuclei of heavy element with emission of certain type of radiation. So it is a disintegration. You must know that atomic number greater than 82, okay, atomic number greater than 82, all the elements are unstable. So unstable means they have extra energy within them. What they do is they liberate that energy and they get stable position or stable state. They acquire stable state. Now heavy element liberates energy and they become stable. So what are the type of energy they liberate? There are mainly 3 types of radiation emitted by the radioactive substances. First one is alpha particle. So you have already heard about alpha particle in the Rutherford alpha scattering experiment. So alpha particles are nothing but helium nuclei, right? They have 2+ charge. Okay, alpha particles are helium nucleus. Next one, beta particle. So beta particle is a kind of identical particle with the electron. So there are mainly 2 types of beta. We usually go for beta negative, but we don't study much about beta positive here. That's the reason why we consider beta as a negative particle. There are 2 types mainly, beta positive and beta negative. It is identical to electron. So it is not electron actually, it is identical to electron, but it comes from the nucleus. So all the particles alpha or beta, it comes from the nucleus. Next one is gamma ray. So gamma rays are high energetic photon. Okay, so they are not particles, or they are actually the waves, high energy waves. So gamma rays are the highest. So if you check the electromagnetic spectrum, you can see the wave having highest energy, it is gamma. Okay, so gamma rays are having highest energy, and It is actually emitted when the high energetic nucleus disintegrates to its stable state. So in the next class we will see about the properties of alpha, beta and gamma. Thank you.